I don't know why. Okay, sorry for the trouble again. So we have S number of, totally we have S number of, capital S number of channels, and N is your cluster size. And what do you mean by K? K is the channels associated with a single cell. Okay, so totally there are N number of cells in one cluster. So the relation between S, K and N will be S is equal to K into N. Okay, any doubts with respect to this equation? What is capital S? Capital S is the total channels. Capital N is the number of cells in one cluster, and small letter k is the cells associated with each cluster. Okay, I mean channels associated with each cell. Okay, how many number of channels are associated with one cell? That is what is known as K. N is the total number of cells in one cluster. Okay, so if you multiply this, you will have S number of channels available in the entire geographical region. Clear? Any doubts? S is equal to K into N.
No, sir.
If the same cluster is repeating again and again, means if the cluster is replicating, why? What is the necessity of replication of a cluster? Why you want to replicate the same cluster again and again? Because we need to provide service for the all the subscribers available in the entire region. Clear? So if there is no replication, means there is no availability of channel. So we have to ensure that somehow this channel is reallocated to everyone. So in that case, suppose there are m repetitions for one cluster. Okay, if one cluster is repeating m times, means how many number of channels will be there in total? As of now, we have S number of channels in one cluster, because there are n cells in one cluster. Each cell is having k channels, so totally there are S channels in one cluster. Okay, and similarly there are m number of clusters, means the total available channel will be nothing but m into S, where S is k into n, so that the capacity of the entire system can now be written as mkn, where k into n can be replaced by S. So capacity is equal to m into S. Is this point is clear to you?
Yes, sir.
Okay. So our intention is to increase the capacity. So to increase the capacity, what we have to do? Shall we increase the number of channels? Can we increase the number of channels? No, it's not possible. Spectrum is always limited. So we are not going to increase the channel, it is fixed. So the only possibility to increase the capacity is to increase the cluster. The number of clusters or the replication can be again and again done. Okay, repetition of same clusters can be done again and again. So that is the only way to increase the capacity of the system. So we can say that capacity of the system is directly proportional to the number of times a cluster is repeated. Another aspect, what will happen if cluster size is reduced? You know what is cluster size? Cluster size is nothing but the number of cells present in one cluster which are not at all sharing the channels among them. Okay, cluster size is nothing but the number of channels, number of cells present in one cluster which are not sharing channels among them, because they will be having distinct channels allocated to them separately within one cluster. So if we are reducing the cluster size, means we are reducing the capital N value, but at the same time the cell size is remaining constant. We are reducing the cluster size, but cell size is remaining constant, means cells area of one cell is remaining constant. Okay, so the only way, the only thing what we are doing is we are reducing the number of cells, but each cells will have the cluster size will be remaining constant. So in that case, what we have to do, we have to create more clusters to cover the entire geographical area, isn't it? So more clusters are required to cover the given area, hence more capacity. So how you can increase the capacity? You are increasing the capacity by increasing the clusters, isn't it? Clusters we are increasing, but cluster size is reducing. Okay, number of clusters is nothing but capital M. Please don't confuse yourself. Capital M is the number of clusters. So we are trying to increase the number of clusters to increase the capacity, as you can see from this particular equation, because C is directly proportional to M over here. So when you increase the value of M, C can be increased. How we are going to increase M? You can increase M by reducing the value of capital N. Okay, so without changing the cell size, or cell size is remaining constant, but the only thing what you're doing is you are reducing the cluster size. So what will happen if cluster size is reduced? Because it has an effect over the interference, isn't it? So larger the cluster size means less interference. Larger the cluster size means less interference. But if you're reducing the cluster size means adjacent cells, or the cells which are sharing the same channels, they appear close to each other. In that case, interference will increase. So whenever you are trying to increase a capacity, you have to compromise in the interference. Okay. Our objective was to increase the capacity initially. So for that, what we have done is we have increased the cluster replication. Okay, clusters are repeated repeatingly more and more. So in that case, what we have to do, we have to reduce the cluster size. Okay, cluster numbers are increasing, but cluster size is reducing. Cluster size means the number of cells present in one cluster is reducing. So which means that the similar cells, or the same cells that is sharing the same channels, will get closer to each other. So that you can see from this figure. See, suppose here in the cluster we are having 7 number of cells, but to increase the capacity, what you have done is you have reduced the cluster size. Okay, from 7 let it be 5. From 7 let it be 5. In that case, what will happen? The cells which are sharing the same channels will appear more close to each other, so the interference will increase. Okay, so though the capacity increases, why the capacity increases? Because you are sharing the same channels to multiple number of subscribers, isn't it? So in that case, the capacity is increasing, but at the same time the interference is interference is more. Okay, so even though we are trying to increase the capacity, but we are compensating on the interference, means we have to adjust something for the interference. So again, that depends on the quality that we require. Okay, so we can say that the co-channel interference. What do you mean by co-channel interference? Interference taking place between two cells that is sharing same channels. That is what is known as co-channel interference. I repeat, co-channel interference is nothing but interference that is taking place between two cells. Why interference has taken place between two cells? Because they have came more closer to each other, isn't it? Why it happened? Because we were trying to increase the capacity. So for that, we have reduced our cluster size. So the cells became more close to each other, sharing the same channel, so interference came to exist. Okay, so co-channel interference has increased because of the reduction in cluster size, because our objective was to increase the capacity. So last point is large cluster size, less interference. So if the cluster size is large means we have allocated more cells in one cluster. Okay, we have allocated more cells in one cluster. In that particular case, we have achieved a large cluster size, means the capacity, it will be little bit less, because we are not able to share the same channel to more number of subscribers, because in one cluster itself we are having a large number of cells. So in that case, we were not able to distribute the cells to more number of subscribers in the geographical area. Okay, so in that case, what will happen is the interference can be reduced, because the cells which are sharing the same channel, now it will be far apart from each other, so interference can be reduced in little. Okay, so we can say that the cluster size is inversely proportional to the interference. Okay, so larger the cluster size means less is the interference. Cluster size is nothing but the number of cells inside one cluster. It doesn't mean the replication number, it means only the number of cells within a particular cluster. Moving on to the next slide. frequency reuse factor. So as of now, you got the value of capital N. What do you mean capital N? Capital N is the number of cells present in one cluster. If you take the reciprocal of the capital N, you will get the frequency reuse factor. So frequency reuse factor is nothing but the reciprocal of cluster size. Cluster size is cells present in one cluster. Or you can say that frequency reuse factor means each cell is assigned 1 by n of total channels. If you have a total channels as x, then x divided by n is nothing but the number of channel allocated to one cell. So you can say that frequency reuse factor is 1 by n. Okay, so 1 by n of total channels. So that number of channels is being allocated to each and every cell in a cluster. Okay, so in that case, 1 by n is called frequency reuse factor. So if 7 is the cluster size, then 1 by 7 is known as frequency reuse factor because you have total available channels with you. So that total available channels divided by 7 will be the number of channels associated to each cell of a cluster. Clear? Now, how you can divide or how you can attain the value of n? N is the cluster size. Okay, so that n depends on a formula. It's I square plus ij plus j square. This is being derived from some geometrical aspects. So no, don't go for the derivation and all. You just need to study the formula that is connecting the values of I, j, and n. And what do you mean by I and j? I and j are some integers which depends upon the geometrical structure of the area. So I'll go to that particular thing. So as of now, you just remember n can be designed based upon the equation I square plus ij plus j square. Suppose if I is equal to 3 and j is equal to 2, then n is 19. If you substitute in that equation, n will become 19, which means that 19 number of cells can be accommodated in one cluster. Clear? For n equal to 7, that is the nominal value for any GSM system, the cluster size is 7. Okay, so what will be the value of I and j for n equal to 7? What will be the ideal values for I and j? Can you predict from that equation?
One and two, sir.
Yes, 1 and 2. So 1 square plus 1 into 2 plus 2 square, isn't it? So 4 plus 2 plus 1, that is 7. Okay, so conveniently you have to take the values of I and j to get the approximate, the desirable value for n. Okay, so what is this I and j? So that I will explain the next slide. So this is the diagram that is used to represent or locate the co-channel cell. What do you mean by co-channel cell? Co-channel cell is nothing but the cells that are sharing the same channels. As of now, I have labeled a particular cell as A. Okay, I need to find another cell A which is distantly placed from this particular cell A. So what should I do? I have to go I times through a particular direction. You can take any direction. Okay, so I have taken I as 3. In the previous example as shown, I have taken I as 3. So I have taken 3 cells. Okay, I have moved through 3 cells and I have reached at the center of the third cell. Then what I will do is I will take a 60-degree turn. Okay, I will take a 60-degree turn. Means this will be a straight line. I will annotate and show you. This will be a straight line, and with reference to this, I have turned 60-degree anti-clockwise, isn't it? Actually, my intention was to move in this direction, but after crossing the third cell, that is I equal to 3, I will take a 60-degree turn to the anti-clockwise direction, and then I will move across 2 cells because j is equal to 2. Okay, and whatever I am seeing the new cell, that can be considered as a co-channel cell with respect to this. Okay, in similar manner, you can find any co-channel cells associated with the desired cell A. So if you take I equal to 3 and j equal to 2, the value of n will be 19. So that 19 number of cells can be accommodated in one cluster. Okay. So if you take this A, let it be 1. Then beyond, beyond this A, how many number of cells are there? 1, 2, 3, 4, 5, 6, isn't it? Near to this A, immediate vicinity, you are having 6 cells. So 6 plus 1 is 7. Again, you count. Again, you count another round. So in that case, you will have 19 number of cells, which can be considered as one cluster. So this is a procedure of locating a core channel cell. Core channel cells means the cells which are sharing the same set of channels. So how we are going to find that? First procedure is you are going to move I number of cells in any direction. Then after crossing I number of cells, you will have to turn 60-degree anti-clockwise and then move across j cells so that j will become, after crossing j number of cells, you will have a cell which can be located as a core channel cell. So how will you assign these values of I and j? That depends upon the previous equation, whatever I have told. Equation is n equal to I square plus ij plus j square. Clear? So in another 1 minute, this meeting will go. It will end. You can join with the same link afterwards. Okay. So this is a procedure of relocating. Locating a core channel cell. In this figure, you have how many number of core channel cells with respect to this A? You have 6 number of core channel cells identified for this particular cell A by using the formula I square plus ij plus j square. Any doubts regarding this phenomenon of locating the core channel cell?